Я просто не знаю, что подороже. Подороже в тех местах, куда я хожу. Конечно, чтобы поехать в это место, где я хочу подешевле.
Есть в этом списке чуть-чуть.
Я думаю, что вот этого там просто нет. Так,
Да.
Дорогая бутылка, которая стоит, наверное, евро 250. Если занимаешься, что это 10.
И даже с лучше. Все, всего 5, 4 в качестве исключения. Счет еще за пределами гравити, но самое старое, еще из списка, если читать читать, что
Yeah, your name and pronunciation is Alexey Lvov. Yeah. Okay. Okay. That's very good. I even called him, some Japanese call me Lvov. But Lvov is It's closer to us. Okay. Is that a meaning? Well, it is the right version of word land. Land. Animal.
そう真面目な。いやいや、半分内職してますね。さっきのお手上げだ。
合ってますね。地名という大学。
あ、そう。
何聞いたことない。
そう。レニングラード。
そうですね。行かれたことありますね。
あそこに有名な物理研究所がある。それで研究所。
ロシア行ったことがないんですよ。
ないの？今時期が悪いけど、機会があれば行くといいですよ。ロシアは、こう、真面目な研究者がたくさんいるから。
そうです。
あれってモスクワでこの会議、モスクワでやれって。
それが難しい。
始まったのはもう5、6年なの。だとね、一緒に日露共同事業で、日本とロシアと交代で順々に。
あ、そうなんです。最初は。
うん。
じゃあもう、かなり長いシリーズ。
じゃあ、僕も京都何年前少なくとも僕が IPM にいたので、7年、8年前ぐらいだ。この僕の試験が終わっちゃった。それでおしまいのつもりで言うと、彼は真面目に続けてる。
Yes, so let's start the second lecture in this morning session. So the second speaker is Alexey Lvov from St. Petersburg University, and the title of his lecture is Coherent sheaves on maximally singular varieties. So please start.
Thank you very much. Firstly, I would like to thank all those organizers for organizing this event and inviting me also. It is a great honor for me to talk here. My talk is based on joint work with Alexey Lvov, and the title of talk consists of word varieties, but in fact our work is still in progress, so main part of my today's talk will be about curves. So now we will work with algebraic curves or algebraically closed fields. Characteristic 0. Well, and let me give the third definition. I will call another curve y a singular model of x if we have morphism from x to y, which is finite, birational, and bidirectional. In this case, I will call y as a singular model and well, this is not a standard definition. So let me explain why I call this singular model. Well, the simplest example of such morphism is just when x is a1 and y is a custom. And this morphism is bijective and just sending, for example, 0 to the singular point. And all such morphisms are of such form that we have some curve for variety x, and we choose some subvarieties and add singularities along these subvarieties. For example, here we choose a point on a1 and add singularity. And interesting thing about such morphisms is the following: we have when we have such morphism, we can look the direct image functor of categories of coherent sheaves, and this functor, first of all, it will be exact and faithful. But this is not very interesting. The interesting thing I want to say is that this functor is fully faithful I'm not sure about double L here. Sorry. And fully faithful on in total free sheaves. In fact, if I have two sheaves on X, F and G is totally free, then we have isomorphism of bond groups. And this fact means that the category of coherent sheaves on X is somehow embedded in category of coherent sheaves on Y. Because we have faithful functor on all objects, so here we have more objects than in X, and on the main part of this category, the functor is fully faithful.
This is not only for this is for arbitrary dimension.
Yeah, this is for arbitrary X and Y and such morphism. And well, in this statement, we get the following idea that we can collect all of such categories just in one category, because we see that coherent sheaves on X have something to do with coherent sheaves on Y. And well, to do this, I define category CX is a category of singular models of X. And just its objects are such morphisms, and morphisms are just commutative triangles. And for curves, there is very simple construction which classify all such morphisms. Well, for curve and for X, then to get such morphism, all we need to do is choose some number of points, finite number of points, and in each point we should, well, we have here structure sheaf, and in each point we should choose subgroup of subring of local ring of structure sheaf, such that, well, I'll call it O prime O. Well, just like this. So it's a ring of local ring of X in this point P, and we can take arbitrary subring of such form for some n. And after we do this, we obtain unique curve of Y, which have such local rings in those points. And all possible curves which are singular models of this are given by this construction. And from this we have next proposition that this category is infinite. And in fact, it is a direct set, because in our category between any two objects, there is at most one morphism. And so this means that if we take our starting curve X and do something with it, so we add some singularities here and add some singularities here, then we can always find a curve which have both singularities of first one and second. And as I say, categories of coherent sheaves are somehow extending when we add singularities. So we will have such a diagram of categories. And when I say that we want to collect all such sheaves in one category, I mean that we can just take a limit of this diagram. And well, let us look closely on the diagram on the left in the category of schemes. Well, in a category of schemes, there is no limit. But there is a limit of categories. So
This one true. We should take up the fiber.
in here, so we have four products in fact in a category of schemes, but there are in our category. This is not the only curve which lies under it Y1 and Y2. So the main definition of my talk is following. We define category of Cx as a limit along this diagram of categories of potentials. And because we are taking limit of categories, it's better to say that this is two limit, but in our case, there are no issues, no categorical issues, so don't mind.
Do you think you can explain what does it mean? What are objects and morphisms?
Yes, yeah, we'll do it first now. So, as I describe objects, well, objects of this category are just coherent sheaves on singular models of X. And morphisms are as follows. If I have two objects of this category, this means that they are, this is coherent sheaf on some curve y1 and this on y2. And in the next, well, from this moment, I will meet symbols of direct image because, well, I will identify. Well, when I consider this f and g as objects in the category of Cx, this is not completely right to write that.
So an object is a pair consisting of y and the sheaf on y.
Yeah, you're right.
And if you have two such things, y1, sheaf on y1, and y2, and the sheaf of y2, then home is some inductive limit over things that.
That's right. Thank you. So, for my category, if we have f on y1 and so let's say on y, and it's direct image, then these are the same objects. And home between F and G will be question.
The I identified the coherent.
Write the formula. No, of course, of course.
I will explain in a moment. So it will be just a limit of homes between
Other things which are under both y and y prime, y1 and y2. Yes. That's the y of images here.
it will limit to all
Yes, yes.
y which lies under y1 and y2, and here I should write push forwards, right? So let me write here push forwards, be more precise, but so this is the definition that we consider our shifts on more and more singular curves and take limit of homes. And well, to explain what is happening, it is good to know that the underlying topological set, the topological space is the same, and we have just functor from coherent sheaves to just sheaves, and this functor commutes with direct image, and therefore we can consider all of our objects as a sheaves of abelian groups on X, which came from some category of coherent sheaves on some singular model of X. So, because of this proposition, so our goal was to collect all the sheaves in one category. So we achieved this goal, but the interesting thing is that if we have two objects, and this one is torsion free, this is correct correct words because direct images preserve torsion freeness, and if you have two such objects, then home in our category between them will be just home of any curve for any well so now I say that this category have a sense as a category of coherent sheaves on a limit on this diagram. Well, I already said that there is no limit, but this filtered category, so we have so-called int object or int object in a category of schemes, and well, I stated that this category is in some sense category of coherent sheaves on this int scheme, and that is how I will explain this a little bit. And for simplicity, I will consider a affine case. So if we started with a affine curve, so its structured sheaf is just a ring or K algebra, then we have all of structure sheaves on singular models. They are in fact subsheaves of this one. And in a affine case, that means that we will have subrings here. For example, in the case of line, this was K of t, and this was K of t squared q to the fourth, etc. And we have inclusion of rings. And so we will have here sequence of rings, which became smaller and smaller. And in fact, there will be a limit in a category of fine schemes, but no limit in a category of schemes. But this is not important. Important is that somehow on a in scheme, the structure sheaf will be the row limit of as an object. Well, in a fine case, it will be just row of K objects. And so now let's think what is the model over algebra. If we have a algebra, the model over algebra is just well, if it's K algebra, then it's K vector space with a morphism of K algebras from A to endomorphisms F to the ring of endomorphisms. And now if you take instead of algebra this object, then
so actual limit is 0.
No, actual limit will be just K because all of
K, yes, already unit, yes.
Yeah, because all structure sheaves
yes
contain constants.
Yes, yes.
But this will be a limit in the category of affine schemes, not algebras. And now if we consider home from this from algebra to the endomorphism ring. Then this thing is equal to direct limit or just forms of rings. This home is in K algebras, and this home is in block K algebras. And so we have here direct limit, and elements of such direct limit are just so to get element of this direct limit, we need to choose some y and choose morphism here on y, and then we will obtain element of direct limit, and we identify two elements if we have similar, if have such commutative triangles. And this means that exactly modules over this thing will be just modules over all over any y. And if you look closely to definition of homomorphism of models, we will have that in our case it should be this, and so there is no other variant for it. So in some sense, this category has sense for category of coherent sheaves on this of this limit, and this limit is what we call maximally singular model of X, because it contains all possible singularities. Yeah, I call it Alexey Lvov, don't label it. Okay, so now I will talk about this category. It has some interesting properties. Well, first of all, this category is abelian. And there is a notion of torsion-free and torsion sheaves in it. And so we have subcategories of torsion and torsion-free. And this form torsion-free. Okay. This is not surprising thing. And let me start saying surprising things. The first and very interesting one is that skyscraper sheaves are injective objects in this category. When I say skyscraper sheaves, I mean just direct images of skyscraper sheaves from X, which are also skyscraper sheaves on any Y. And this fact is very unusual for categories of coherent sheaves because, for example, first text from skyscraper sheaf to itself is a tangent space for algebraic variety, but here we have first text 0. Well, so next thing I want to say that from this fact, we immediately have that torsion part of this category is very simple. It's just direct sum of categories of vector spaces for all points of finite dimensional vector spaces. And any sheaf is a direct sum of its torsion part and torsion free part. Because all torsion sheaves are just direct sums of skyscrapers and they are injected. They are exceptional. Yeah, from the fact that they're injective, it follows that they are exceptional also. Well, but it may seem that our category became very simple and trivial, but this is not true. Because for example, well, first of all, to study homological properties of our category, it is useful to know that we can compute derived forms just by taking limits. This will do for usual forms. So this will be limit over all y where f and g live. And also so the more compact way to say it is this one. Okay. And so now why our category is not trivial? This is because we have such property that if we have f which is finite, birational, and bijective, and we have two sheaves here on y. And we assume that G is torsion free. Then we have inclusion on the first X groups. This is induced by F star because it's exact quantum in this case. And the statement is that this is monomorphism. So we see that when we add singularities on the first X2 torsion-free sheaves, we have inclusion. And this means that when we will take limit, it will just grow up. And because of that, we see that already our category is not homologically trivial. And that's interesting.
Already for the sheaf force, or you take home from O to O in your limit category. What do you get?
Is all from O to O, just O.
Yeah, text one.
And
so it's also not trivial.
well, 0 x, yeah.
Yeah, but home to preserve home from O to O will not die.
Yeah, that's right.
Okay.
So also we know that any singular variety have category of Coherent sheaves on any single variety is homologically infinite dimensional. It have global dimension equal to infinity, and because here we take limit of x, we may think that in our maximally singular curve we also will have non-trivial higher x. But the surprising fact is that that is not true. So theorem that for any curve, global dimension of the scale is equal to 1. Well, let me give an example. We can consider just local curve.
So this CX1, C1X.
They're amazing.
So let us pick local curve. By local curve, I mean it's just spectrum of local rings. So we have one point and one closed point and one open point, and for this x, we also can define all of previous things, and so we have here Ox, for example, we can think of it as our series, and this is in a case of complete local curve, but that don't really matter in this case, and well, we can pick cofinal subcategory in Cx consisting of a curve of such form that is our series which have which do not have powers of t from the first to n minus one, and we can just assume that we take limit over such curves, and we will have the following result. If we consider firstly the structure sheaf of the main curve and a skyscraper sheaf of this point, then our category will be generated by these two objects, and we have such mixed algebra between them. So the form will be isomorphic to k over Ox, where k is the field of rational functions, and here we will have first text, which is also isomorphic to k over Ox, and there will be a relation. In fact, yeah, and here home is Ox. Here home is just k. I mean lower bound k, and the relations are such that first x is there's a product of these two things factorized by another k over O, which is the factor is taken as a OX by model, and this is now the shortest way to define is to say that this is zero quotient homology, or just elements of this bimodal which have same action from the left and from the right of OX. Well, also these arrows are K over OX as OX module, not modules. One of them is right and another one is left. Okay, so now well, that answer is just given us. It was not expected that it will be such. And also there are no higher texts. And then there was several approaches to prove this fact. I will now tell the idea of the most clear one. The most clear one is to consider not just coherent sheaves on CX, but quasi-coherent. And to do this, we will consider category of int objects in our category, just int completion of it. This is reasonable because for schemes we have such property, and we will have here more sheaves. For example, here we will have sheaf which has meaning of constant sheaf of rational functions. This is because we have from exact functors from quasi-coherent sheaves on our singular curves to this category, and here we have sheaf of rational functions, and its image will be sheaf of rational functions on CX. Well, position is the following, that I will define this sheaf as kx of k, and this object is why is it to write this formula? It was injected. And in fact, it will be injected. And quasi-injective means that we have here inside our starting category, and the functor com to this object will be exact on our category. And so now we have this injective object, and also skyscrapers are also injective. And because of that, now we can write the resolution for any sheaf, which is in fact quite simple. Well, we have some sheaf G, then we will have such exact sequence First of all, G have torsion, and torsion free part is G. Well, this will be exact sequence in block of Y for some Y. Here will be and well, this sequence gives us nothing in coherent sheaves of Y, but if we now imply functor 3Y, then we will have this thing injected. This will be also injective as a direct sum of fields of rational functions. And this thing, here it was in Q-core. Here it was torsion sheaf, and when we take limit, and when we imply this functor, it will be just a limit of coherent torsion sheaves, which are direct sums of skyscraper. So this will be isomorphic to infinite direct sum of skyscraper sheaves. And it will also be injective. And because of that, our category have global dimension 1. And we see that here we obtain it from the fact that our curve for all it points, the local rings means the images of, and we have also general point, all skyscraper sheaves are injective, and also you can say that this is skyscraper and general point. The field of rational functions is also injective. Okay. How much time I have? 15 minutes. Okay. Well, so now I will say more about this case. Also, we have Grothendieck duality on our category. That is just because when we have a finite directional morphism, then we know that we have such isomorphism. F star F. And these things are just Grothendieck duality factors. And because of that,
Little f is a model, right?
yeah. And it is exact functor F star, so I don't write L here. And so we have there is which is anti-equivalence, and its square is equivalent to identity. And also this can be given by also pair home to dualizing sheaf, where we define this as a object in Hop. use of Cx. So on our scheme we have the Lessing sheaf. Well, and another interesting thing which I can say about one-dimensional case is a statement by Benzvi and Nevis. Well, they have paper on a singular curves, and well, their result one of their result can be reformulated as we have exact and faithful functor from our category to category of D models on a starting curve S. And because of that, there is an idea to give another definition for our category as D models with some additional structure. But that is about work in progress, and also about work in progress is higher dimensional case. Well, we don't have such a good classification for high dimensional finite operational morphisms that we have for curves, but it seems very natural to have well, we can place similar definition for our category, and so well, our conjecture, which we are now working on, is that for smooth variety of dimensions D, then and from example of curves, we see that sheaves with dimension of support n have injective homological dimension n. So the homological dimension of sheaf in such category should be equal to dimension of its support. And well, it seems to be true, but there are some limitations because of higher dimensional things. Example for curves, we have fact that any such morphism we can get like this. We have some closed subschemes. And Y is the contracting of such diagram. And here, this is like a peak scheme, and this morphism erases this thickness. Yeah. So for higher dimensions, it is not clear whether finite and rational morphism could be given by several steps of such procedures. So it's interesting to understand whether it can or not, and I think this is a more reasonable definition here. So, well,
definition categories X.
Yeah. So we finish here. Thank you.
Is there any question or comment?
Also, I want to mention very useful conversations with Anya Nanskova and say thank you to Michelle Vanderberg for useful communication.
Minutes? Maybe explain why this is Coherent sheaves.
Why it's faithful?
Why it's this?
How
Yes, what is dx?
if you consider curves and our finite directional morphism, then well, for it works for in a case when some restrictions in x and y, for example, they should be coined maybe there are some.
Will be faithful even without the corner.
So such factors are by well, I'm not sure now about notation because I wasn't expecting I will say some details of this. But we have like this factor is tensoring by dx, and this thing is tensoring by this standard notation. I'm not sure about arrows here, but we just take tensor with such sheet. And the statement is that these arrows are so this triangle is commutative up to natural transformations, and also in fact this bimodal dx the y model gives equivalence of categories of d models on y and d models on x.
The main point that the models are given categories for instance.
Yeah. So again, the models on x and y are Morita equivalent, so the categories are equivalent. So answer some questions.
Any question? So sheaves of dimension 0 are still decomposed as the direct sum of skyscraper sheaf in any dimension.
That's yeah.
Is there any easier similar description for sheaves of dimension 1 or
Either what?
yeah, in dimension 1? Sheaves of dimension 1. Yeah.
Well, dimension, it is clear that also rational functions are the sheaf of top dimensions of work will be quasi intuitive. But well, about curves inside, if you have some curve inside X, then it is clear that, for example, we can take singular model of each. And there will be a singular model of X which contain this curve instead this, for example. And therefore we will have functor from if it name this type, you will have functors. And here we know that the field of rational functions here is quasi-injective. And we want to show that it is quasi-injective here, but this thing doesn't imply it immediately.
Yeah, one question.
So can you describe the image of this functor in terms of DD modules from CoFCX to model DX?
Image of this functor in terms of D modules. Yeah, there is
What's the word? It's not fully fixed. So right question is how to change the category on the right hand side.
And I have an
Something one answer.
generic.
This for American language.
Version 3.
Because, yeah, it's good.
No other question?
Describe the derived category of CX as something like a localization of the derived category of X or something.
I'm not sure. In derived category of X and in a category of X we have infinite dimensional poles.
Okay.
So I'm not sure about it.
You should mod out some category.
Yeah, it's not confined.
Much more.
It can somehow contains Coherent sheaves on all the singular models as a full subcategory. It's for
But
species. It's the private. You have sheaves on all singular models, but somehow at the end you got something smooth again.
and the whole example of this idea is to get a definition of this category in terms of some differential geometric data on X. And this will be very interesting because this category is somehow naturally defined from X, but to define it we need to use a lot of things, all singular models possible. But it will be interesting to know what it is just in terms of X. And it seems that there is such definition.
Okay. So if there's no more questions, then let's thank the speaker again. The morning session ends and we will resume at 2.
Well, it was long with this one.